Oil Discharge Monitoring and Control System. ODMCS components are located in two areas, hazardous and non-hazardous areas. An analyzing unit is installed in the pump room. A sample feed pump is mounted in the engine room bulkhead, and the electrical drive motor is located in the engine room. The converting unit is also installed in the engine room. The system's computer unit is installed in the cargo control room. The analyzing unit contains the sample water measuring unit, measuring cell, connections for inlet and outlet of sample water, a pneumatic line inlet for operations of the pneumatic valve for sample water, piping for cleaning liquid, flushing water, and few cable inlets for the intrinsically safe power supply and measuring signals. A fresh water supply, either from the ship's freshwater service piping system or a small freshwater header tank, is supplied by a check valve to the analyzing unit for the automatic flushing of the measuring cell during each starting and stopping of the cycle. The converting unit consists of two sections. One is Zener barriers, for the intrinsically safe measuring signals and the flow meter signals. Sample feed pump relays and circuit breakers, power transformers, and various cable terminals. The other section is a container with cleaning liquid and the associated pump for feeding cleaning liquid to the measuring cell at controlled intervals, and a pneumatic solenoid valve to control sample flow through the measuring cell. Small diameter tubing for pneumatic signals is routed between the converting unit and the analyzing unit via approved bulkhead penetrations. The converting unit has input connections for electrical power, compressed air, and output connections for measuring signals. Further, it has the necessary signal cable connection to the computer unit. The computer has a single-phase power input, command and communication signal connections to the converting unit, and input connections for a signal from the ship's speed log. It provides output signals to operate pneumatic solenoid valves in the ship valve control system for opening the overboard valve and closing of the return valve to slop tanks when acceptable overboard discharging conditions are sensed and vice versa. It also has a display of relevant current data and a printer for recording all of data required by the regulations. Initially, the ODMCS is put to operation in a condition where the overboard valve is closed and the slop tank return valve is opened by interlock mechanism of ODMCS and allowing system to stabilize. Sample of the water being discharged by the cargo or slop tank pump is taken by the ODMCS sample feed pump, and it is sent through the measuring cell of analyzer unit, where it is subjected to a light beam infrared light path in a quartz tube. Oil particles emulsified in water scatter the light, and the amount of light scattered is proportional to the number of oil particles, and thus to the oil concentration expressed in parts per million, or ppm. The oil concentration is detected by measuring the scattered light with photodiodes. The optical information thus obtained from the measuring cell is transformed into electrical signal by amplifying circuitry in the converting unit and is further fed to the computer control unit for processing. When the calculated rate of discharge of oil, 30 liters per nautical mile, or maximum oil content, 15 ppm, or the total quantity of oily water discharge reaches beyond the permissible discharge value as per regulations, the computer activates the audible and visible alarm, thereby closing the discharge valve immediately and opening the slop tank return valve. Then, the cargo or slop pump should be stopped. And in the event of ODMCS failure, the computer closes the overboard valve and opens the return valve to the slop tanks, thereby activating visual and audible alarms. The pressure differential signals from the flow meter is used in the computer to represent the overboard flow rate. The ppm information processed in the computer, along with other information like discharge flow rate and ship speed, are used to calculate oil discharge rate in liters per nautical mile and total quantity discharged overboard. The computer printer automatically prints out at regular intervals of, say, 10 minutes the following information. Discharge rate of oil in liters per nautical mile. Oil content in ppm. Total quantity of oil discharged in cubic meters or liters. Time and date. Ship speed in knots, effluent flow rate position of the discharge valve oil type, alarms or warnings. Failure. In other words, no flow, fault, and so on. Override action. In other words, manual override, flushing, calibration, and so on.